In this video, we're going to talk about computing probabilities involving sampling, meaning if we have sampled a group and we're going to talk about their sampling and how we find their probabilities. So first, let's look at the survey for a college that was conducted by the Centers for Disease Control to determine college students' health risk behaviors. College students were asked, how often do you wear a seatbelt when riding in a car driven by someone else? The frequencies appear in the following table. So these are people that when you're riding in a car driven by someone else. So 125 responded that they never wear their seatbelt. 324 rarely wear their seatbelt. 552 sometimes wear their seatbelt. 1,257 most of the time wear their seatbelt, and 2,518 always wear their seatbelt while they're riding with someone else driving. So a survey selects a single student at random from this population, meaning from one of these students here in this group. What is the probability that the sampled student wears a seatbelt most of the time? So the first thing that we need to do is find out what is our sample space. Well, our sample space is all of these students here. Therefore, we need to know the total number of students that were asked. So we add these up. So our N, or our total sample space, is our total frequency. It's also equal to our total frequency. So whenever we add these up, N is going to equal to, there were 4,776 students that were surveyed for this particular survey. Now, we're looking for those that wear their seatbelt most of the time. So those that wear their seatbelt most of the time fall into this category. There were 1,257 that answered that they wear their seatbelt most of the time. So we want the probability that most of the time was their answer. And so when we do that, we want the number for most of time, in other words, what their answer was most of the time, divided by the total frequency. Just like we've been doing in our other probabilities. And so we get the probability that most of the time there's 1,257 divided by 4,776. We divide that out or simplify that into the lowest terms, and we get that it is 0.2632. So the probability that a randomly selected student wears a seatbelt most of the time is 0.2632. Now we need to talk about unusual events. These are events that are not likely to happen, or events whose probability is small. The problem with unusual events is that there is no hard and fast rule for these. In other words, there's no real cutoff that everyone in the statistical world or research world uses as, okay, here's the cutoff, anything below this is considered an unusual event. The rule of thumb, or most, tend to use 0.05. Medical tends to use a lower cutoff because they want to be much more accurate, as well as engineering. They want to be much more accurate in their designs and everything. Therefore, they want this cutoff to be much lower and be more accurate. I want them to be much more accurate as well. But most of the time, for research purposes, surveys, things of that nature, we can use the 0.05 cutoff. That means that events with a probability less than 0.05 is considered to be unusual. So let's continue with our college survey, and we still have the same frequencies, and we're still asking about riding in the car driven by someone else. And what we want to know here is, if we look, never is the answer that was given the least. So would this be considered an unusual event or an unusual occurrence? So if I do the probability for this, so the probability of never is equal to the number that answered never divided by our total, and you can add these up and get your total again, which was 4,776. So I'm going to take 125 and divide that by 4,776, and I get 0.0262. Looking at this probability is much less than 0.05. Therefore, based on the most commonly applied rule, this event would be considered an unusual event, since 0.0262 is less than 0.05. This event would be considered an unusual event. Again, if you're talking about medical terms or anything along that nature, they may use maybe 0.005 or some of those rules. So you have to go based on what your field of study is wanting to use to figure out what would be considered an unusual event. Now, sometimes we want to approximate probabilities with the empirical rule. We've looked at the empirical rule before, and recall that the empirical rule was stating that things that are approximately bell-shaped, items would be closer to the mean, things of that nature. So the empirical method, what we do is consists of repeating an experiment in a large number of times. This way we have that large number of data to look at, and using proportion of times an outcome occurs to approximate the probability of an outcome. So we predict things using this empirical method. So for example, there are 100,000 voters in a city. A pollster takes a simple random sample of just 1,000 of them and finds that 315 support a bond issue to support the public library. 487 oppose. Estimate the probability that a randomly chosen voter in the city supports the bond issue. Well, when you're talking about voting, anything like that, you're obviously not going to be able to poll all the people. So what we do is we take that sample and we try to make the sample large, so 1,000. And of those 1,000, we found that 513 supported the issue and 487 opposed the issue. Therefore, if we select anybody else in the city outside these 1,000 voters, we want to know the probability that they will support the issue. So what we do is the probability of support is going to be equal to 513 over 1,000, which is going to be 0.513. In other words, we estimate that probability based on our sample. we look at what our sample was and find its probability, and we make a conjecture based back onto the population for that particular area. Now, if we go outside the city, then we have to do a new sample and sample some from each city, different things of that nature. Okay? Practice more with probabilities, and if you have questions, please let me know.